So I will go for add beam method, finish it. But we have seen the dead load, right, for a big building.
Yes, yes, you see.
Similarly, like I will tell you today, like for beam analysis and all. Okay. Okay. So first of all, like it is having 7 meter, okay, and 2 kilometer in between. So I can just put a 7 meter. So I just made a 7 meter beam.
Yeah.
And as usual, we need to go to property and then define. We need to put some cross section, right? So it is by default concrete and assigned to the beam. Select the beam and assign to the beam. Okay, now we need to go to support. So create fixed support and use cursor to assign in the sense like otherwise like you can select the nodes, control, select the nodes, assign to selected nodes. Okay, now loads and definition, load case detail, add. So here like now we will consider live load. Okay, in this live load again I will add the concentrated load. Okay, so for concentrated load, which is going to act on a member, we need to go for member load. Then here you have concentrated force. How much it is? -2. When it is acting downward in global Y, you need to put minus. And no need to put any distance since it is in the midpoint. Add. Then that one you can assign to the selected beam. Okay, now you can see how it was applied, 2 kilonewton. Okay, now we can go for analysis and print all. Then analyze, run analysis, same procedure. But before we are using dead load, now we are using concentrated load.
Mm. But
Okay,
there is one, look, there is one wrong.
what wrong? We are not getting
Error
any error.
zero.
Zero error, one warning. That doesn't matter.
Warning. Yeah.
I can errors. We should not have errors, but warning we can see all degrees of freedom fixed because we have only one beam. Na, we don't have any columns, and that beam it is having fixed. That's why it is in warning, and we can see the results. And we can go to post processing, and you can see the displacement displacement for live load. You can see okay, and then reactions and the beams forces bending moment. You can see the bending moment, shear force, okay, and then everything, okay, and then you can see the graph. Can you see this graph? It
Yes.
will work. So you can see mx, which means like mz, fy, and fx. Okay, so fx means axial force. So we will not have axial force for horizontal member, but we have BMD and SFD diagram here. Okay, okay. Now like I will go. Now I can go for another thing there. Okay, next one is 9. So I can just put 9. So 9, the same way, go to general property and again select it and assign to the selected beam. Since we created already, no need to create again. Support also we created already. So select the new things and then assign to selected nodes. Only now like we have two different concentrated load. How you can do? So go to loads and definition. No need to create again. Just you can put here itself again add. So member load uniform no concentrated force, and now it's supposed to be -3, but at which distance? 3.75. So you need to put that 3.75 here. Add again like -2, that it's supposed to be 3.75 plus 3.25, which means like 7. Add. If you have distance, you need to do like this. Then you can select the beam and assign to the selected beam. Okay, and then assign to the selected beam. Can you see now two things it's coming on a one beam?
Yeah.
Okay, now like we can go for analyze because the analysis input we already gave na, so again and again no need to give. So post processing mode. Now you can see for both. See the deflection and beam. You can see here it was different. When you select here, like you can see the graphs. Accordingly, you will get. Got it?
Yeah.
Okay. Now again, I will go. So snap node beam. Next one is 7.5. How you will put 7.5? So what you can do means like you can just put a node, shift K so that the node is visible. Select the node and go for translational repeat in X direction 7.5. So link steps. Click OK. So now we got this is very simple way of creating like this. Okay. Now
Okay.
general assign to selected beam. Okay. Then support select these two nodes assign to selected nodes. Then loads and definition. Now it is like UDL. How you can create the same. You go here add, but in the member load you need to select the UDL. So member, but uniform force you need to select. How much? Minus 2 kilonewton meter. No need to put any values because it is all over the span. Again, select this and then assign to selected beam. Okay, now we got this also. Now we can go for analyze. Now you will get post processing according to the conditions. You can see. So deflection for three different conditions and you can see the reactions for three different conditions. But when you have like this now, you can use text, select text and you can just drag like this. So you can see separately what are all the value. Okay. Then you can go to beams and you can see the bending moment and the graph. This graph is more practical. You can see directly by clicking separate beams. Okay. And another thing, you can double click and you can also see the shear bending and deflection at different points. Okay. At this point, how much? 1.4 meter, Fy equal to 1 kilonewton, Mz equal to 0.35 like this. And when you click, it will change also. This is bending is that, shear is that, shear Y, you can also see the values. Okay, that is double click and you can see, and even the deflection also it will applicable, but in Y direction, deflection will be in Y direction. At this 1.4, we have 0.027 mm, very negligible deflection. Okay, now you got it right.
Yes, yes.
Okay, then go to modeling, then click snap node. Again, like 7.5. So again, 7.5 in the sense like we can select the same, but better if you are another way of creating 7.5. Na, so I will put 8. Then I can go to geometry, insert node option, and I'm putting 7.5. Add new point, click OK. So then we can
Again,
select and
delete.
delete. Yeah.
Yeah.
This is also another thing. As usual, select, assign to the beam, support, assign to the selected nodes. Okay, now like here we have only at the particular span. Then how you can go? Select, remove, add again. So member load, uniform force only, but minus 2, right? But the distance 1 is 3. Then the distance 2 is 6. You can see in the preview itself. then you add, then it will be assigned to the beam accordingly. Can you see it is coming only at the particular value what you are putting?
Yes.
Okay.
But there is more here. In the picture, it's only 5.
Where we are doing the fourth exercise.
We are doing in D, right?
Yeah, exercise 1.D. This is correct. Okay, actually in the book now they are considering as a simply support. For that, like we should not consider fixed actually. Okay, that is also there, but we consider everywhere fixed. But if you want to consider pinned, then I will tell you the next exercise. Now it was correct. Now I will go for analyze. So no error means it's good, so that we can go for post processing. Otherwise, it will not. Now you can see the beam bending moment diagrams and all. And for the this one, you can see for this one, like you can see, it was like a different. But for this, it was different. But for this also, it was different. Got it?
Yeah, yeah.
But now, like I will go for modeling, but the final one, I will put as a pinned support. How many things? Like 1.5 na, so what we can do means like I just put node, then you add everything. 5.75 plus 2.25, how much? 8 9
9.5, I think.
9.5. Okay, so what we can do is like select this translational 9.5, better. Link steps, click OK. Okay, now like I will go to general, but we can assign this to the assign to selected beams. Okay, now I can go to support, create a pinned support, because there it was only arrow na, which means like simply support a pinned support, add. Now you can assign to this nodes. The second one, assign to the selected nodes. You can see pinned support, it was looking different. Fixed support, it was looking different. Only thing, like we need to put the UDL, loads and definition. So select, add. Okay, member load, uniform force. How much? Minus 2 at which distance? 0 and then 1.5. Okay, you can add it. Then minus 3, and it was like 5.75 plus 1.5, how much?
Mm,
7.25, right? 7.25. Then I am putting 9.5. Then add. Now this you can assign to the selected beams. Okay, and selected beam. So it is similar to the exercise we got. Got it?
yes.
Okay. Now like analyze. So output file. This is like we are going for the outputs file. Na? So why it is also having another warning? Instability at joint because of the pinned support. Okay. This is because we have many disjointed beams. Na? That's why. Because we have beams separately, which means like disjointed warning, and pinned support like instability warning. Now you can go to post processing, select. Now you can see. So the deflections, reactions. See, can you see? You can see the pinned support, it is having free everywhere. So pinned support in the sense like it is having restrained in translational effects FI FZ. But we can able to rotate the particular object in rotational. So rotational, it is showing free. Okay. But in the fixed, like we have all values. So this is what the difference between fixed and pinned. What is an example for pinned support? A door. A door is a example for pinned support. Pinned support or hinged support, both same only. Okay, when you have pin at one point, you can able to rotate the door in degrees, but you can't able to move that door in any of the axis, because it was pinned there. Got it?
Yes.
When you have pinned, it can able to rotate freely, but it is having restriction in the translational displacements. Okay, okay, that's why here we have, and you can see the instability in the sense it will show at this point because it is pinned support. Okay, then we can go for beam, and you can see, and better you can go to graph and select. See, for this, like you can see the bending moment, shear force diagram, axial forces. So got it, that page exercise we completed. So five
Yes.
different. So now you understand how to apply point
Yeah.
load and also UDL at different parts of the beam. Then how to analyze. Okay.
Yeah.
Oh,
Can you send me like more examples so I can practice on it?
yeah. Now I will send you. Now you can practice this also, right?
Yeah, yeah, I will practice on it.
Now I am sending. Can you able to see that values and all clear, right?
Yes.
This is like pinned fixed also they have. Yeah. So you just practice the next one. But for the next one, it is a triangular load. So for triangular load, how you will go? Go for modeling, then general loads and definition. Here you have, when you click add, you can go for member load, and here you can go for linear varying, and you need to select W3 and you need to put, so that the triangular load you will get. Shall we do that now?
Let's make only one.
Only one, yeah. So that one like 9, so I can put a 9. Okay, 9, and then I will go to property and assign the selected beam. So support that is pinned support only, assign to selected nodes. Okay, now loads and definition. So add, so member load, now it is triangular load, linear varying, and you need to click the W3. How much? Minus 3, right?
Yeah, -3.
3. Okay, and then add. Okay, select it and then assign it so that the question mark after the assignment it will go away. Okay, great. So we got it. Now we can analyze. Now for that condition, for that support, like we will get the post processing. Go to post processing mode, click OK. Okay, you can see here how it was. Okay, now control scroll to make it bigger or smaller. That representation, reactions you can see, and instabilities. Okay, and then we can go for beam, and you can see control scroll. So as a whole, and then we can see one by one. As a whole, also you can click here these values. If you want to show the values, go to results view value. This one, right? Shear force, annotate. This it will show the values. But apart from that, like we can go to graph and separately we can click each and every member. So this one we did. So you can see how the SFD and BMD it's coming. Now you got right. This is very simple beam analysis with the different
Yes, yes,
loading condition and different support conditions.
yes. May
Oh,
you solve like 2C also?
2C. Yeah, yeah. Okay. So go to modeling. So 2C, go here. So 2C 6, right? Okay. Yes, 6. Okay, general, you need to assign this, that is essential because cross section. Then support, but support, you need to assign only to this node because fixed at only one end. Okay, now we assign only to that particular end. Got it? Now only
Yeah.
you need to put the point load, loads and definition. So add, we don't have -4 before now, that's why we can create again. Member load, concentrated force, -4. Add, but it's supposed to be, we can edit it. It's supposed to be at the end, na, you can edit, you can put the distance as 6. Okay, this is important. Just assign to the selected beam. So at that, it was not taking na. So what you can do means like a D2. I was putting D2 na. You supposed to put D1. So here D1 only you can see change. You can see this is how like we can go for analyze. You got it right?
Yes.
Yeah. That is a kind of cantilever thing, na. That's what. Uh, Fixed at one end, free at another end. This is how cantilever works, na, because of the plate load. You can see instabilities and then the beam graph. Can you see? It was like when you select this, then you can see the SFD. This is BMD and SFD. And as a whole also, like when you click, you can see the shear forces or bending moments or the deflections. Okay. So got it.
Yes.
Okay. In the next set of exercises, you can see 2 point E. Okay. Can you see that one 2 point E?
Yes.
Okay. So total how much distance? 2 plus 5 plus 2, like 9 meter.
9.
So what I
Yeah.
will do means like I can go to snap node, then I can just draw the 9 meter beam. Okay. Okay. As usual, go to general, but now like we can able to assign the property. Okay. Okay. But then how you can provide the support at a particular point? We have support, but it was pinned support. Then you don't have option to edit, but it was not on the notes, it was in between. So how you can do? So for that what we can do means like select the beam and go for a geometry insert node, and you can put 2 meter, add new point, then 7 meter, add new point. Okay, then click OK. Now you can see, now like you can able to assign the support to the nodes. Okay, assign to the selected nodes. Okay, but you need to make the member as a physical member. So you should not have separate member. Okay, what we can do? So select the beam, control, select all the beams, right click, form member. There is one option called form member. When you click that one, this is no more a beam. This is a physical beam. Okay, so you also have a cursor for it. Now like you can go to loads and definition, put live load, add. You already have the uniform 2 kilonewton, right? But that is for the beam. If you want to put that to this beams, like yeah, otherwise like I can create a physical member load. Okay, add. You can go to physical member load. Now you understand why we have separate physical member load. in that uniform force of how much? Minus 2 kilonewton. And no need to put anything. Add. Okay, then you can assign to the member. Okay, but we need to select the physical member cursor. You can see here. This is load editor cursor. This is also geometry cursor. Can you see the physical member cursor in select option?
Yes, yes,
Yeah, go to select physical member cursor and select it. Can you see it is all together getting selected? This is not a member
yes.
anymore. Then you can able to assign to the use cursor to assign or select this and then select the thing. Then what we can do means use cursor to assign. Okay, now you can see we assigned using use cursor to assign option. Now like we can analyze. So go to post processing since we don't have error. Done. Can you see how it was like behaving as a physical member? Okay. Then you can see the beam also. You can see control scroll down to see the values. Okay, and you can see the graph. Select this is like a physical member, right? It was just taking 18 and 19. What if I'm selecting physical member? Select everything. Okay, so this is like taking separately. Okay, but as a whole also we can see, right? But that's better. Like physical member, you should do. Okay, and here you can see when you click beam, you can see the total forces. When you click forces, you can see as a whole. Okay. So got it. Now, like you understand what you mean by physical member, how to select
Yeah, yeah,
physical member, and how to form
yeah.
the physical member. So when you form physical member, like you need to apply load also for physical member, not for the beams. Okay. In that also we discussed 2.A and then 2.E and also 2.C. Only two is pending.
Yeah, and the rest is the same.
Yeah. The 2.D also similar to 2.C.
Yeah, yeah.
Okay. Do you want me to do that?
No, no, no. I will try.
Okay. So anyway, we will try the 2.D also. Okay, wait a minute. So how much like 7 meter, right? Uh,
7.5.
okay, okay. No, no, seven. Yeah, 7.5 it was. Okay. Select the node. So translational repeat and X 7.5.
Yeah. How you select the node?
Node cursor, link steps, because we need to select the node cursor, right? Then we can
Yeah,
go
yeah,
for
but how you click on it or what?
no, I just do like this. You can click also, it will
Yeah,
select.
yeah, 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 yeah. Thank
So go to general as usual, assign to selected beam. Now like go to support. This one is support at only at one node. Okay, one node assigned to the selected node. Okay, then we can go for loads and definition. So that one is minus 2 kilonewton, but we need to create better. You can see if it is physical, it will show as physical. So to avoid confusion. Now it is not physical. Separately, uniform force of minus 2, but it was 3.75, 3.75, and then 7.5. This only you need to put, nothing else. Okay, assign to the selected beam. So you can see it is coming only at the next half. Okay, now we can analyze. So view output file or post processing directly. Click OK. You can see here how it was. So this is the displacement, right? Reactions and the beams. So bending moment diagram, shear force diagram, control so that you can see control scroll to make it bigger or smaller. Then as a graph also you can go one by one. See for this. Okay, I hope you understand. So practice both
Okay,
sheets.
yes, I will practice on it more. If
Okay,
I have any doubt, I will.
okay. Now I'm stopping.
Okay.